So take a moment, pause the video, and try this question on your own. Find the derivative of this function, this polynomial, and then use it to find the equation of the tangent line to the point. So take a moment to pause, and then we'll work through it after you've finished. Okay, so let's go ahead and work through this one. I'm going to compute the derivative. Now it's a polynomial, so it means that we can use that method of derivative of power x cubed. That becomes a 6x squared. So the 3 multiplied to the 2 gives us a 6, and the new exponent is a 2. And this is minus 14x plus 3, and the derivative of 4 is 0. So at the point 1, 2, what is the derivative? Well, dy by dx, when x is 1, is equal to 6 times 1 squared minus 14 times 1 plus 3. So that's 6 plus 3 is 9 minus 14, so that's negative 5. That's our derivative or our slope of the tangent line. So what is our tangent line then? Our tangent line is y minus the y coordinate of the point you know is equal to the slope times x minus the x coordinate of the point you know. Or in other words, it's y is equal to negative 5x plus 5 plus 2, or y is equal to negative 5x plus 7. And so there's the equation of the tangent line. Okay, in this last example, we want to find the equation for the straight line that passes through the point 0, 2 and is tangent to the curve y equals x cubed. Okay, so take a moment and pause the video and try to work through this on your own. Okay, so let's have a look at this. I'm going to get a rough sketch of what's going on here. We've got this cubic curve, y equals x cubed. It looks something like this. So it comes down, goes flat around the origin there, and then it takes off again in this direction. So that's our curve y equals x cubed. What's this point 0, 2? Well, it's sitting at x equals 0, y equals 2. So somewhere up here. There's our point. And what we're interested in is a tangent line to the curve that passes through this point. So at this stage, we don't know where we're computing the tangent line to the curve at. That's the thing we're going to have to try to find. So let's have a look at a visualization of this. What I've done here is I've sketched in red the cubic. Blue is a tangent line to a point on the curve. And this is allowed to change. I can move this point anywhere I want and construct a new tangent line. What am I interested in? I'm interested in finding a point on the curve for which the tangent line passes through the point 0, 2. Okay, so that tangent line should be somewhere around here. In fact, it seems to be snapping right onto it. It looks like the point that I need to find is -1, -1, so that when I construct the tangent line there, it's going to pass through the point 0, 2. Now this suggests what the answer is going to be. However, and we're only doing this just to give us a good mental picture of what's going on. We still need to do the calculations to actually see how we can come up with this point. So let's go ahead and do that now. How do we come up with that point? Well, from the picture, we get a rough guess that, well, any tangent line over here in quadrant 1 is never going to pass through the point 0, 2, because any tangent line over here is going to look like this and then pass through the y-axis at some negative y value. What we're interested in is a tangent line somewhere over here, wherever it actually is. So we need to find this point. We don't know what it is. Okay, so if we don't know what something is, and we want to try to figure it out, what we can do is we can call it by some variable name, some unknown, and then try to figure out what the value of that unknown is. So that's what we're going to do. We're going to let A be the value of this unknown that we're trying to find. Now we're going to find the tangent line to the corresponding point. What's the corresponding point? Well, if x is a, and it lives on the curve y equals x squared, then we know that y has to be a cubed. So we're going to find the tangent line to a cubed. What is the equation of the tangent line? Well, it's y minus the y coordinate of the point we know, which is a cubed, is equal to the derivative at the point. What's the derivative? Well, the derivative of x cubed is 3x squared, so at this particular point when x is a, this will be 3a squared. And that's times x minus the x-coordinate of the point we know. So that's the tangent line at any given point along the curve corresponding to the x-coordinate of a. What we want to do then is just sort of massage it into a form that's a little bit easier to deal with. So 3a squared times x, 3a squared times negative a is negative 3a cubed plus the a cubed that I get from moving this minus a cubed from one side to the other tells me then that my equation of my tangent line is that. Now this is the equation of the tangent line for any given a. What do we want this tangent line to have? What property do we want it to have? We want this line to pass through the point 0, 2. Let's jot that in our diagram. There's 0, 2. We want it to pass through that point. So what does that mean? Well, it means if we take x equals 0 and y equals 2 and plug it into the equation above, it should satisfy that equation. So y equals 2, x equals 0, gives us an equation 2 is equal to negative 2a cubed, or a cubed is equal to negative 1. So it gives us an equation that a must satisfy. And this tells us then that a has to be negative 1. So we know what a has to be. It has to be negative 1. And therefore, the point in question that we're constructing the tangent line at is negative 1 cubed, or negative 1, negative 1. Now, we were asked to find the equation of this straight line that is tangent to the curve, so the tangent line. We now know that it corresponds to a equals negative 1. We have the equation for any tangent line, so we can go ahead and plug that in. So the tangent line is y is equal to 3a squared, a is negative 1, so that's 3x, minus 2 times a cubed. Again, a is negative 1, so this would be plus 2. So that's the equation of the tangent line, and is taken at the point negative 1, negative 1. So it's taken at that point. That's where the tangent line is taken to the curve at. So the tangent line is this, and is taken at that. And this tangent line is the one that passes through 0.